Today we'll be talking about factoring with special cases. It's still just factoring. The stuff you learned before doesn't change, only now we can find shortcuts. And basically we might as well call this factoring with shortcuts. Recognize that factoring is just doing multiplication backwards. Like we learned about how to multiply a plus b squared very quickly. If we had like 3x plus 2 squared, we know it becomes 9x squared plus 12x plus 4. Because we did this thing squared and this thing squared, and then this times 2. Something we learned before. Same if it's a minus, you can subtract or multiply the minus very easily. A difference of squares, like x minus 3 times x plus 3, becomes x squared plus or x squared minus 9. This is something that's, again, shortcuts, useful, but not necessary. You could still do this multiplication by just foiling things out. So the shortcuts I'm going to show you aren't necessary. You can still factor the old ways. I can find two numbers that multiply to 25 and add to 10 because the a value is 1. When the a value is 1, find two numbers that multiply to c and add to b. You can still do that, but the shortcuts are nice. They can make things go much faster and easier. So basically, I check for this pattern. A square number here, a square numbered here, and an even number there. And if ever that happens, I'm pretty sure this can factor into x plus 5 times x plus 5. Because 5x and 5x get me the positive 10x that I needed. So we actually just call that x plus 5 squared for its factoring. Same with this one over here. This number is a perfect square, this is a perfect square, this is even. And if that happens, I'm pretty sure I can just do x minus 8 times x minus 8, which is just x minus 8 squared. Because 8 times 8 is 64, but negative 8x plus negative 8x is negative 16x. It's a pattern that doesn't always work, like if I had x squared minus 18x plus 64. Well, yeah, that's a perfect square and that's a perfect square, but 8s don't work. 8s get me to 16, not 18. But it's at least a good thing to try for a shortcut. Check and see if you have that pattern there. The other pattern, and this one is way more common and extremely helpful, is difference of squares. If this number is a perfect square and this number is a perfect square and they're being subtracted, excuse me, it doesn't work with addition, it only works with subtraction. If they're being subtracted, you can always just take the square root of this thing here, which is x, and the square root of this thing here, which is 10, and do x plus 10, x minus 10. That is how that factors. It's this process here done backwards. Factoring is just multiplying backwards. So I could check, x times x is x squared, x times negative 10 is negative 10x, positive 10 times x is positive 10x, positive 10 times negative 10 is negative 100, and we get x squared minus 100. Just like we wanted to. So, sorry, that was a check. This is a check. This right here is the actual factoring. Sometimes things don't look like perfect squares. Like 2x squared is not a perfect square and 98 is not a perfect square, but both of these have a factor of 2 that I can pull out. When I pull out the factor of 2, now I do have perfect squares. X squared and 49 can both be square rooted, so it's 2 times x plus 7, x minus 7. That is how that one factors. Now sadly, I can't pull a 4 out of 25. There's no greatest common factor for me to pull out of this problem. But what I can do is recognize this is still a perfect square because 4 is a perfect square and x squared is a perfect square. So if I were to square root that, I would get 2x. This is also a perfect square. So it's 2x plus 5 and 2x minus 5. (2x plus 5, 2x minus 5). Again, I could check 4x squared plus 10x minus 10x minus 25. So it checks. This is my factoring. Recognize this is not a difference of squares because that's a plus. This is actually not factorable. It is prime. sum of squares isn't something we can work with. It's only a difference of squares. If I tried to factor it into x plus 4, x minus 4, this isn't going to work. Because when I check it, x times x is x squared. Excuse me 1 second. I have somebody at my door. Okay, I'm back. I know for you that was like a split second, but for me it was like 10 minutes. I had somebody vacuuming my room, somebody came to the door, I had to help Kaylee with her annoying questions. I can't even remember what we were talking about. Was it Catching the Rye? Declaration of Independence? What? Oh, factoring. We're factoring this. So I was going to show that this doesn't work, because you get x squared minus 4x plus 4x minus 16, which gives you x squared minus 16, which is not this. Those are the same. And you might think maybe x plus 4 times x plus 4 can work. But we know the middle terms here combine, because there's x squared, but then there's a 4x, and there's a 4x, and there's a 16, and that's x squared plus 8x plus 16, which is not this, because this one is prime. If it's not a difference of squares, you can't factor it. It's always, if it just looks like this. So you can always try to factor it, but this one can't factor. Just a couple more and we'll be done. Remember, whenever you can pull out a greatest common factor, you should. In this case, I can pull a negative 3 out of everything. Now this actually matches that pattern from before. Here's a perfect square, here's a perfect square. 1 is a perfect square. Always remember that. 1 squared is 1, which means that 1 is a perfect square, like how 2 squared is 4, which makes 2 a perfect square. Or sorry, makes 4 a perfect square. And 3 squared is 9, making 9 a perfect square. We don't need any of that right now. Just remember, 1 is a perfect square. This factors into x minus 1 times x minus 1 with a negative 3 in front. But if you ever get stuck, you can always just think, okay, I have an a value of 1. So what are two numbers that multiply to 1 and add to negative 2? Two numbers that multiply to 1 and add to negative 2 are negative 1 and negative 1. I want to multiply to 1 and add to negative 2. And if you don't like having the extra variables over here, I know that can throw people off, then what I recommend is just ignore them for a while. I'm just going to pretend like the y's aren't there. This factors into 3x plus 2 times 3x plus 2. The square root of this and the square root of this. And I'll check that. I want to make sure that that works. You know, there's 9x squared, there's 6x, there's 6x. 6x and 6x is 12x. 2 and 2 is 4. And now I'm going to go back and attach the y's to the end. So it's 3x plus 2y times 3x plus 2y. Hope that makes sense. Hope that was helpful. Hope you're having a nice day. See you next time.